Hello, everybody. Thank you so much for joining us here today. My name is Paula Basili, and I lead up communications at the Center for Geospatial Solutions. For those of you who may not be familiar with CGS, CGS is a nonprofit geospatial technology organization that works with organizations in the nonprofit, public, and private sphere, helping them better leverage advanced technology, tackle data, and really make better decisions to help usher in a more equitable and sustainable world. Our specialty lies in three things: data modernization, data fusion, and data storytelling. And it is part of our data modernization efforts that we are involved in supporting the vision for the Internet of Water, which we do as a co-leader of the Internet of Water Coalition, which is why I'm really excited to be speaking with all of you today and to serve as the moderator for today's webinar. So before we get started, I wanted to just cover off on a few housekeeping items. The first is you'll notice that this webinar is being recorded. That recording will be available on the IOW Coalition website, as well as the IOW Coalition YouTube channel about a week after today's webinar, just in case you want to forward it to your colleagues or visit any of the content that we cover off on today. You'll have that available and ready and handy. The second is we really encourage participation. So if you have a question for our speaker today, please don't hesitate to drop it into the Q&A function of this Zoom chat. We will be covering questions during the presentation, as well as saving plenty of time at the end once our speaker concludes for a full Q&A. So please, no question is too silly. Drop them into that Q&A function, and we will be sure to address that. And then lastly, if you do have any technical difficulties, our team is available via email at internetofwater@lincolninst.edu. We're always monitoring that inbox. So also, if you have any ideas for other topics that you'd like to cover, if your organization is gearing up for an exciting new tool launch or is really eager to share some lessons learned, please let us know. The IOW Coalition is really meant to be here as a cheerleader for all of the great work being done to help aid our water data discovery journey. So please reach out and don't hesitate to let our team know. And with that, I'm excited to introduce today's speaker. We are joined today by Bo Uriona, and Bo works with the Snow Survey at the National Water and Climate Center. He has been there for cumulatively over 14 years, 11 years doing field work. So really an expert in this space, and will be chatting with us today, walking us through the new REST API that the team developed to really help make all of that information even more accessible for you all. So with that, Bo, I welcome you to join us, hop off video, and I'll let you take it from here.
Wonderful. Thank you for the introduction. And I just wanted to clarify, I'm going to go ahead and give a little bit of background on our organization, where we come from, and then talk a little bit about some of our existing products and tools that are out there for you folks to use. And then we're going to kind of conclude, and I'm going to spend a little time talking about our newest tool, which is the REST API. Historically, we've only had a SOAP web service, and XML tends to be something that most people, the bar for entry is pretty high, and so we're really excited to have a REST API that should really open up the ability for people to leverage our database. One of the first things I like to just say right off the bat is that the Snow Survey, we collect snow data, and we're one of the few agencies that does that in the nation. But we're really doing that as a means to an end, and we're trying to make forecasts. We're trying to make streamflow forecasts, seasonal streamflow forecasts for rivers and streams in the West that are snowmelt driven. And that means that we don't just collect snow data, we collect data from a host of other sources. And that means that if you have desires for hydrologic data, oftentimes we can be quite the one-stop shop for you to get data, especially in the Western United States, to do analysis and studies. So anyways, without further ado, I'll kind of jump in. I always like to let people know SWE, I'll be talking about SWE quite a bit. Snow water equivalent is just the amount of water in a snowpack if you were to melt it down. 10 inches of SWE in a lot of contexts, or 10 inches of snow, new snow at 10% density would equal 1 inch of melted water. And so if you have, 10 feet of snow, and you might end up with 1 foot of water when that snow melts. Our science really came to the study of snow and its relationship to the stream flow really came from Dr. Church back in the late 1800s into the early 1900s. He developed the snow science that we still use today. He realized that Lake Tahoe could be forecasted by measuring snow on Mount Rose, which he started in 1906. He then made some relationships using some pretty rudimentary math, was able to determine that there's a correlation between the amount of snow in the mountains and the amount of runoff that we see. And he developed a lot of the techniques that we still use today. I'd encourage anyone to, yes.
Oh, just really quick, I don't think you're sharing your slides yet. I'm not seeing them on the screen.
That's not what we want.
All good. I know you had some great pictures for that one, so want to make sure folks get to see them.
Yeah, I think I just lost the little bar, so there we go. I do need to start sharing. Okay, we'll start over here. So just to go back, so yeah, snow water equivalent, just the measure of the melted snow. Dr. Church started the snow science back in the early 1900s and established some practices that are still used today. Currently, every year, thousands of measurements are made using the exact same methodologies that he came up with. So during the early 1900s, many snow courses were developed. Snow courses are basically just places where we measure snow at the exact same place every year at roughly the same time, beginning of the month, usually the 5 days leading up to the month. And so let me see if I can get this out of the way too, because I think that might be. Typical snow courses these days have 5 to 10 measurements spaced at around 50 feet. And oftentimes they're marked with this configuration you see here. Snow course measurement, they basically just use a tube, stick it in the ground, pull it out, and it's a really clever way. The diameter of the tube just happens to be set up perfectly so that 1 ounce of snow inside that tube equals 1 inch of water. Until the 1970s, pretty much all snow that was used for that was measured in the United States was done by hand, and slowly in the 1970s, 80s, and so on, telemetered measurements were started to be made. They started out as dailies, and then now we're actually collecting hourly measurements across the Western United States at over about 1,000 snowtail sites. So we still have about 1,000 sites that are actively measured by hand to this day, and some of them have been measured for well over 100 years. You can see here a timeline. People really realized the utility in this very quickly, and pretty much everyone in the Western United States and the snowmelt-driven hydrology areas jumped on board, and soon enough, the federal government realized, well, they ought to just create a national center that handles this sorts of stuff, and that's where we come in. The Natural Resources Conservation Service used to be called the SCS, but now is that. The snow survey is administered from 5 DCOs. You can see marked on this map throughout the Western United States, as well as the National Water and Climate Center, which is where I work. And the National Water and Climate Center sort of handles a lot of the database administration, as well as the forecasting of the stream flow based on that data. And then the field offices in the various DCOs actually maintain and install new snowtells and snow lights, all the meteorological stations that we have in the mountains. We have 902 as of today snowtells, 213 scan sites. These scan sites are the red sites. They're typically near or on farm, and they're very much soil moisture driven. Snow lights are just a small version of a snowtell. We only have 43 of those. Like I mentioned, there's over 800. There's 800 snow courses right now, as well as 243 that California measures, and some in Canada. And then we also pull in other snow pillows that are much like our snowtell sites from both Canada and California. It's worth mentioning that way back in the day, the slide I showed a minute ago, when all the other states were kind of realizing that they were all doing these snow surveys, and the federal government took up the mantle and started doing it for everybody, California decided to stick it out on their own. And so the snow surveys in California are still done by the Division of Water Resources there. This is a typical SNOTEL site. This site has a host of sensors. You can see precipitation gauge that actually collects the rain throughout the year. The meteor burst antenna, I should probably remove that. We're no longer using that technology. Most of our sites are telemetered via GOES or cell or Iridium modems. But this is the basic gist of it. You put all this stuff out and it measures throughout the entire winter. If you look at the bottom left of your screen, you'll see the snow pillows sensor, which is basically just a big water bed full of ethanol so it doesn't freeze. And the pressure that's induced on that can be then measured in a transducer and converted into the equivalent amount of water that's sitting above it. Moving on, a snow light. You can see this is a much smaller footprint. Typically, it's just air temperature, soil moisture, and snow depth. Snow depth can often be used as an analog to determine SWE if you have a good estimate for density in the region. So typically, these might be used to put out their very low footprint. You can then estimate the density based on a host of different methodologies and get estimates for SWE based on that as well. Scan sites, as I mentioned, these are more on-farm. This is part of the NRCS and USDA's kind of other set of meteorological stations. But since we have a good database for this data to go into, we kind of manage that part of it. And they're throughout the entire United States, since they're not really tied to any snow-driven hydrology sort of thing. So these are especially great for if you're doing any soil moisture kind of drought studies. The data here can be super useful. Just wanted to point out that it's really important to remember that manual measurements are monthly, whereas we have hourly and daily for pretty much all these other telemetered stations that are out there. So, all right, that's a bit of a background on what we collect, but I also, like I mentioned, want to point out that we collect a lot of other data from a lot of other agencies, and we, aggregate it, slice it, and dice it, and serve it up via our various products and tools. So we're kind of a one-stop shop for a lot of hydrological and climatological data. I might suggest that we're a good place to start looking if you're going to be doing a study around hydrology in the West in general. And so hopefully by the end of this presentation, I will have convinced at least a couple of you that maybe that is true. So the first thing I wanted to point out, we kind of have two websites. This is something that happens in the government a lot. We have a web content management system that kind of hosts our informational and contextual information, a lot more text, a lot more sharing of general ideas and such. And that's that link at the top of your screen. That's our homepage. But really all of our data-driven tools and products live under the NWCC apps domain. And these are the things that most people think of when they think of our products. These serve up all of the data that we have in our air and water database, which I'll be referring to as AWDB for the rest of this presentation. And so I just wanted to always make sure that if you see a page that looks a lot like the one on the top, you're probably on our kind of informational web page. And I'll be spending the majority of the time after this showing you examples of tools and products that we have on NWCC apps. And you'll have a look and feel that will be consistent throughout that. So the first one I wanted to touch on is our interactive map. This is by far, I think, our most used product. A lot of people are familiar with it. And actually, I think I did already open up a link. So I'll continue. I have these links here. All the links that I'm going to be walking through now are in the PowerPoint. I think the PowerPoint's set up on a timer, so it might just continue to loop through as I talk about these things. But I wanted to make sure that I let you know that you'll have these links if you snag a copy of the PowerPoint presentation. So our interactive map, I like to often start out by showing people the extent of the data that we have. These are all the stations that are within our database are shown here. If I scroll down a little bit on this, you can see some of the numbers associated with them. And it really kind of shows the amount of data that we have in our database. Again, some of these snow courses have periods of record that are over 100 years old. Most of our snow tells, there's a big push for installations back in the early 80s. Most of them have 30 years of data, but obviously as we continue to install snow tells, some are much younger. And so there's kind of a mix. Some we've established climatological normals, both medians and averages for them, but many of them are kind of new. And the name of the utility of data, hydrologic data, I'm sure as many of you are aware, is really in the length of its period of record. If you want to make relationships, you need that period of record. And one of the main things we really strive to do around here is maintain consistency and period of record across our data sets. And so I just wanted to make sure that people know that although this looks like there's a lot of sites, many of these are maybe going to be sort of new sites and might not be as helpful. So the interactive map has many different metrics that you can look at. If you only want to look at the sites that have snow measurements, you can see them here. But let's just jump in and look at some actual station conditions. I'm going to bump it back to April 1st, and I'll hit first of day. April 1st is often the day that we refer to as kind of the most important snow day of the year. A majority of basins throughout the Western United States tend to peak at or near April 1st. And so our April 1st forecasts tend to be when streamflow forecasts tend to be kind of when the quality of the forecast really comes into focus and we start trusting them a lot more. So you can see here that, for any given metric, you can pick a variety of parameters. And so there's business logic behind this that does these calculations for you. And this can be incredibly powerful because it takes a long time to come up with these analyses yourself. So I would highly encourage anyone to jump on and, start looking at, the percent of the water year peak on April 1st. You can see that this year, many were near average, but some just didn't quite get there. And you could see that if we were to, jump back a couple months, you're just getting further and further away from that water year peak. And I think many of these sites throughout the Western United States did near average this year. We kind of had a pretty near average year. But yeah, just all sorts of different metrics, and those metrics, what's available for you to look at will change depending on the element that you pick. So we could even look at the change in SWE, over the course of 30 days, unlock, and all sorts of all sorts of different stuff to determine different things that you might be interested in your region. We have things like snow depth. It's important to know that we don't really have central tendencies for snow depth, so it'll seem like it's blank. We don't really have the climatological averages set up for those, so you have to just use the period of record average, which kind of hasn't been quality controlled as well. But I would encourage anyone to come in, play around with this stuff. There's so much data in here that you can look at. And one of the views that a lot of people like, because it gives a broader spectrum of what you're looking at across the country, are these basin filled. And it's important to note that these are simply, these basin indices, as we call them, are simply the arithmetic average of the sites within or nearby and associated with those basins. If a site is really close to a basin, we might include it if it's a site that could be considered useful in that calculation. However, we do take into consideration things like rain shadow effects and stuff like that, especially in areas like the Sierra where it's really pronounced. And so, I think a lot of people are used to seeing these basin views of our data sets. And one thing I like to point out to people is we publish things in as HUCs, which are hydrologic unit codes. These are kind of like the official. These are the official basins throughout the United States, but it so happens that we have water supply specialists in most of our states. And what they do is they kind of take a look at what's important within their state, and they define these custom basins that are always a combination of various HUC levels, but they might not fit the exact HUC. And so it's really dependent. It's really dependent on the water supply specialist within a state to determine this. And so we could look at, Nevada, for example, their basins, their water supply specialists determine that this is how these basins should be laid out to be of the greatest utility for folks. So I had a question here, and I'll just go ahead and answer it quick because it's easy. The period of record is quality controlled for data and for snow depth. We quality control all of our data, but we publish official 30-year normals, we call them, both medians and averages. And we ensure that all the data that goes into those, we can like cut out datas where we had, or years where maybe there was a fire early on in the record and it doesn't match. It's not, the stationarity doesn't look good. We can cut out years and do all sorts of stuff like that. And so we can quality control those official climatological normals. And so I always suggest people to be looking at that. It's also important as we see effects of climate change that we shift those climatological normals every 10 years. And so it's 30 years right now. It's 1991 through 2020. And that gives you a better example of how this year compares to the recent past. Whereas if you compare it to the entire period of record, sometimes you can look, way out of line with what's been happening in the most recent past. It's a really important thing. And I actually have a link in this PowerPoint that will take you to a lot more information about that. And I'd encourage anyone to do so. So that's how our state custom basins, and I'll use air quotes because we don't really know what to call these, but these are basins as defined by water supply specialists in these states. Oftentimes they consult with water conservation districts, managers, all sorts of different things to determine how these are laid out. You can poke through and see how that goes. So I'd highly encourage people to spend some time in the interactive map. It's a really powerful tool. It's almost too powerful. But if you spend some time with it, I assure you that you can kind of figure out how it all works and take it from there. So I don't want to spend too much time because I really do want to get to our newest tool, the REST API. So I'm gonna move on from the IMAP and talk about these interactive plots, which are also one of our really popular tools, because this, in one place, you can see all of the data for a given basin, site, or so I'll move on. You can see that we have these sorts of plots for sites, our straight HUCs, I like to call them. So those are based on the hydrologic unit codes, and for the basins as defined by the water supply specialists. So here we are in Utah's state custom basins. And if we wanted to look how the Weber-Ogden looked this year and contextually throughout time, we can come in here. There's a lot of bells and whistles that you can add things and take things away, so you can have a better way to make something for a presentation. If you don't like the colors, you can always grayscale them. You can clear some annotation, and then maybe you want to save a PNG and use that in a presentation. It's available for you to do exactly that. So the beauty of these things is you can compare years. Basically, that's really what comes down to. I just so happen to know that 2019 wasn't so different than this year. So you can see here that it's a great way to look at how years compared to others. These colors are based on, and there's some information about this, the statistical shading are based on the percentiles. And so you can kind of see, if you're in the green, you're pretty well, near median for that year. And as you get into the bluer shades, you're wetter and wetter, and the redder shades, you're drier and drier. And again, you can, put some of these together that are good examples, and then make it so that the legend only shows the ones that you want, and then go on and do that. I also like to point out to people that this median peak, this is a question that often comes up. The median peak is you take the 30-year climatological set of data, and you figure out the peak from each of those years, and then you take the median of that. That's why it's not the same as the peak that you see on the daily medians, because it's a completely different data set. I always forget what the mathematical property is there, transitive or something like that. But since you're slicing the data in different time steps, you wouldn't expect them to be the same. Very often, the peaks are higher for the yearly than the dailies, because if you think about it, some years the peak happens here, and some years the peak happens here. And so this average throughout the year is going to get toned down by these early ones and brought up by these later ones. So this daily average tends to be subdued. Whereas when you actually take the medians of the actual peaks themselves, you get a better metric to measure against. And I also like to mention to people that oftentimes, if you're looking at snow data, you really should be looking at it as it compares to the median peak for the median peak. Because if you compare it to just these daily medians, you're not really getting the right picture. And oftentimes, when we're in a time like right now, we're in this basin. And here, I'll go ahead and turn back on the annotation. You can see that we're at 1,300% of normal. Well, that's not surprising when you looked at the normal is actually, almost zero. And so since the normal is maybe 0.1 and we're sitting up here at 1.5, we're almost at 15,000 or 1,500% of that for the year. So if you were to compare that to the peak, you wouldn't see that, obviously. We'd be well under, 5% of the peak or something like that. So by using the median peak, you really can kind of get rid of some of this garbage data. It's not garbage data, it's very real. It just it's not helpful in any sort of snow analysis. So again, I just wanted to, I'll just point out that we have versions of these for sites. So individual sites, you can go and take a look, as well as the custom ones here, and the ones for the straight hucks like this, and they're all laid out like this, so you can look at all the various hucks that are within these larger regionals. And so moving on, I like to show people the streamflow forecast charts. This is a tool where we'll be publishing for June in the next day or two, probably. So I'm going to back it up one month and take a look at this. This basically just highlights the forecasts for a given region. These are the state custom basins. And it lays it out so you can kind of see how you're doing throughout that region. 100% of median is right here on this gray line. And you can see where all of these, regardless of their magnitude, lie in relationship to that. And that's kind of the beauty of these charts. It kind of normalizes the data away from its magnitude so that you can just kind of see how you're doing within a given basin. Very often we see that these basins tend to follow a trend throughout the whole basin. Whereas if I was to jump over to, an entirely different basin, we're probably going to be on the other side of that line, because Utah had a better year in general than what we saw in Colorado this year. So these are actually very powerful as well. I always encourage people to not overly focus on the interactive maps metrics for snow water equivalent, especially in the basin context. A lot of people will look at this stuff and say we're 1,300%, we're having an amazing year. But again, if you look at the chart, there's only 2 inches of water as far as an index goes in this basin. So it has very little to do with anything. So I'd encourage you to go instead and look at the forecasts for a given region, because the forecast is going to give you a much better idea for what we would expect. And again, these forecasts aren't out quite yet for this month, so we'll jump back a month. But these, we collect the snow data to make seasonal streamflow forecasts. So this is your best metric for knowing how we're doing, even, in the context of snow for this year, because the streamflows typically relate to those snowpacks. So I really encourage people to don't try to pin the quality of a snow year on the numbers that you're seeing in the snow. Look at the forecast. We put a lot of work and effort into our forecasts, and they're a much better indicator, especially on the tail end of the hydrograph, or not hydrograph, of the ablation season as snow melts, to give you an idea of how we're doing for the year. So moving on, our report generator is basically you can make all sorts of crazy reports with this. It's very much only site-based though, no basin context here, but you can pick any different type of site, and pretty readily I know. Well, let's do this. If you know the name of your site, type it in, it'll help you out. And then we want to look at, the snow water equivalent for the last 30 days, quickly make a report. There are many different metrics. We have a lot of ways to slice and dice the data within this, and a lot of ways to look at it as well. You can, look at it in context of chart. You can look at it in context of different ways we lay out the data in water year format. Stacked, this is stacked water year. Oftentimes this is helpful for if you had pulled in the whole year's worth of data. Anyways, it's an incredibly powerful tool, and I would highly encourage people to spend some time with this as well. It also can output CSV formats, which can then be machine readable. A lot of people use this as an API. You can parse your URLs, and then if it's the same thing over and over again, you can just keep hitting that with the updating data, and it will work. But it certainly doesn't follow any like RESTful standards. If you're looking for an API with a more standard approach, we'll be getting to that shortly. But it still is a very powerful tool, and I talk to a lot of people that use this as an API essentially for our data sets, because it certainly can give you the information that you need. But again, I would probably encourage people to start moving towards the RESTful API or the SOAP web service if you're really interested in pulling down data in mass anyways. So moving on, our update report, this is very much a legacy product, but it is still very powerful. You can select for any given state and create a host of, or region, I should say, a host of different reports. We have some special reports here as well. And then, different types of reports for those given region, states, or special reports. And so if we wanted to look at the, precipitation, or let's look at the snowpack update report for April 4th for Colorado. This will put this into a basin context. This was really our first basin tool, and really we've done a lot more development over the last several years because of the popularity of products like this. People really like to be able to think about snowpack on a basin level. And so this was kind of our first attempt at that, but it is certainly aging out. I will even say that some of the basin definitions, as far as which sites are in which basins, might be out of date. So this will probably be replaced in the somewhat near future, but again, still a very powerful tool. And a lot of people really like this tool, and so it will be hard for us to actually replace. But we'll see where we get with that. Okay, so now we're moving on, and I think we have about 10 or 15 more minutes, and so I really want to spend the rest of the time talking about ways to get our data programmatically. And so for about 15 years now, I think, maybe even, 2007, I believe it was, we've had this SOAP web service. SOAP was, all the rage at that time. The XML is really falling out of favor, and unless you're someone that knows what Maven and Spring mean, then you probably don't care. You have to be kind of a Java person to typically be into using this sort of stuff. But it's still very powerful, and there's actually a lot of libraries in popular programming languages like Python and even some JavaScript that can leverage XML, very readily. And so if you're interested in that, I'd encourage you to reach out to me, and I can help you along with that too. Yeah, so this is a great question, and I'll touch on it before moving on. So again, California decided way back in the day to do their own river forecasting, their own collection of snow data. And so we actually don't really make forecasts for much of California, really only the stuff that kind of flows towards the east. So the east side of the Sierra, the Carson, the Walker, the Truckee. And that's really just a decision that California made. And, you know, we certainly work with them quite a bit. And I know several people, in fact, I've worked with some people at the California Nevada Forecast Center for years. But we actually are probably going to start pulling in their forecasts into our system, and so that we can display it. But that's not really our highest priority, obviously, since we really want to focus on our forecasts. But we do have a new forecasting system, and I'm going to touch on that a little bit later, that makes it a lot easier for us to make forecasts, kind of expand our domain. But one of the big problems we have is the snow quality. The quality control on the data in California doesn't really meet the standards that we need to operate on, and that's the big reason why we don't really use that data for forecasts. In some places we do, but we actually have to go in sometimes and actually edit the data ourselves, which is pretty tough for us. So I hope that answers your question. So anyways, back to here. You know, there is, if you come into the SOAP web service, you know, you can start learning how to use it. Again, it's an XML. It's kind of old technology. Not many people really prefer it anymore, but you know, we could see how many sites are above 10,000 feet in Utah just by doing that real quick. And if we want to know only ones that you know, have SWE in them, then we can do that. And obviously there's fewer. I think there's only like one site probably above 11,000. None, in fact. So anyways, this is the request. So you can use this to kind of learn how it all works and make your requests. And then you'll get responses that are also XML. I would highly encourage anyone doing this that's not making stubs in Maven in Java to look into using a wrapper in whatever language you choose. I particularly in like Python, like Zeep a lot, ZEEP, and it can really help you leverage this. But again, one of the things that I really wanted to highlight today is our new REST API. And so let's move on to that. People that aren't familiar with REST APIs, the way I usually describe it to folks is it's just a standard that kind of says that you're going to be able to put a URL into a browser and get data back. I mean, there's a lot more to it that you can different post and get methods and whatnot. But at the end of the day, for the average user, really what this translates to is if I want to get some data, like let's say we wanted to come in and you know, get some metadata for some stations, much like the one I was just doing there. So if I want to do that, I want to get only sites that have SWE, and I'm going to do it for, there's a lot of wildcard stuff, and that's all explained in our docs here. So if I want to look at SNOTEL sites in Utah that have SWE, go ahead and do that. This tool, it's called Swagger Page, it helps you craft some URLs, and after you kind of get the hang of it, you can start crafting your own. And then it also displays the responses, and all of our responses are JSON. We might end up serving some other response types, but for now we're sticking with JSON because it's very much standard that people like working with. Anyway, so anyone that's kind of used to programming languages knows how to deal with JSON, and it's pretty easy to do so. And so our REST API allows you to get, we have 4 different endpoints that really combine, our SOAP web service had like 30 different methods, and you can get all the same data in this REST API just using these 4 different methods. And so our data endpoint allows you to get the actual data for a given site. Our forecast endpoint serves up forecast data. As I mentioned, the forecast data is produced in-house every month during the forecast season, typically January through June, sometimes much shorter seasons depending on where you are in the country. Our reference data is really just a way that you can see, we are the government, so of course we're going to use acronyms. And so if you don't know what our network acronyms stand for, you might want to come in here and spell it right and see what all these different things mean. So when you see SNTL as a code, you'll know that it's SNOTEL. It's the Snow Telemetry Network Stations. And so these are kind of lookup tables that you can use to get long name descriptions of all our different things. One thing I always like to point out to folks is that we probably, this was 30 years ago, likely, we probably chose bad network names for reservoirs and for stream flows. We chose BOR, which is usually associated with the Bureau of Reclamation, and USGS, which is the Geological Survey. And those are two agencies that collect a lot of data. Well, just because we have the network called USGS doesn't actually mean that the site is a USGS gauge. It just means that it's stream flow. And that was a decision that was made so long ago, it would be almost impossible for us to change it now. So I just want to make that very clear that USGS does not mean that it's USGS. It simply means that it's a gauge, a stream flow network. Same thing with Bureau of Reclamation. Does not mean it comes from the Bureau of Reclamation. I think we might even have more Corps of Engineer sites in our database than we do Bureau of Reclamation. Kind of just a poor choice. But these reference tables are great. This is actually a brand new endpoint that kind of can help you display data in a new way. And then station metadata, which is really likely where you're going to start. As you explore what we have to offer, you'll make queries that will then return answers, data sets to you, and you can start looking at, so it's one thing to know that, all these sites have SWE. Well, what kind of, maybe you don't know what kind of durations they get. So if you have it return the station elements as an example, then you get all those station elements that are available to you. And so you can see here that now there's the station elements object, which tells you that you can get daily, semi-monthly, hourly, monthly SWE at that station. And furthermore, you might not even know what you want to get. You just want to know what's out there. So I'm just going to put in one site so we don't blow this thing up. But let's see all the different types of data that this one site has. And so you can see it's quite extensive. We have batteries at many different time steps, incremental precip. And again, if you don't know what that means, we have that reference data endpoint to illuminate that for you. And so on and so forth. You'll be kind of amazed at how many data objects we have for a given station. So soil moisture goes on and on. We're still looking at different things that you can retrieve from our database. And I'm scrolling quite far. Tmax at many different time steps. So we've done a lot of work to derive data for you. We do the slicing and dicing. We do the aggregation. You should be able to dig in and get a good idea for what you want. I might suggest you limit it to, the type of duration of data that you want, because again, those can get very big. Most all of our fields support wildcards. So if you want to know everything that starts with, well, let's do with P, you can just wildcard that, and that'll give you an incremental precip and water year precip, as well as snow adjusted precip, which honestly, I think we're getting rid of soon as a metric because it's not very helpful. But the wildcarding is pretty powerful. Obviously, that one's a little bit silly, but I'd encourage you to read through our documentation here and see how you might be able to leverage those to get what you want. Something I haven't touched on yet that I always like to is this concept of triplets. All of our sites have a site ID that we add the state that it's in and the network it's under. And those three things together that are colon delineated is what we call a station triplet. And the station triplet is basically our primary key for a given station, because there might be a USGS ID of 1099 that we want in our database. And so we don't want to limit 1099 can't be used by any other. So if you change that to, I mean, obviously USGS uses 9-digit, I think, numbers. So that wouldn't be the case, but I think you get the idea here. So the station triplet is an important concept to understand. But, you know, a lot of that can kind of just get spelled out to you as you look through the metadata that we store. And so I think we're running pretty late. So I wanted to hop over real quickly to a Python notebook I put together that I think if you're into this sort of thing, and this is something that you want to pursue, our new REST API, I think if you spent a little time with this, and I've posted it on our GitHub, as well as my full presentation, which I've obviously kind of abandoned. But again, these are links to all these tools that I've been showing you, as well as a host of other kind of more one-off products that we have that I think are also very important. But down here at the bottom of that, presentation, the GitHub repo is there, and I would encourage you to take a look at that. It's right here. Pull down the code, clone it, and real quickly, I'm gonna jump in and reconnect this and just kind of walk you through. I just want to try to convince you, I don't know if I'll be able to, that with a pretty low amount of effort, a pretty low, you know, number of lines of code, you can come up with some pretty powerful analyses. So these are just some setup functions that I built. You know, this pulls down the reference data, this pulls down station list, metadata, pulls down the actual data, this formats the data into a format that I need. This gets forecasts, prepares that forecast into a format that's useful to me. And then I'm just going through here and I'm getting those stations. So basically what I decided to do is the Roaring Fork basin, which is part of the Upper Colorado River, and which is part of the Upper Colorado, and it's a relatively small basin. It's at the Huck 8 level, but the thing that's really nice about it is it has a pour point. So if I switch over to showing the basins, right here is the Roaring Fork Glenwood, and it's basically the pour point of this entire basin. So any snow up in the mountains here eventually flows down here when it melts. And so it's a pretty good thing that you might have a similar desire. You might have a basin in mind that has a pour point or some collection of basins that are important to you for whatever reason. And I just want to try to convince you that it's relatively simple to take that with the pretty simple logic that I've built here, up above there, and get a list of stations. I want to pull all of our SNOTEL stations, USGS networks. So these are streamflow gauges and reservoirs within that basin. I have to do a little manipulation of the data. I pull down the metadata for those stations using those methods that I outlined above. And then I only care about the one forecast point that's at the pour point. I'm not going to worry about the frying pan. This is really just the outflow of a reservoir. So I'm going to drop that from our analysis. That's what I'm doing here. Put all that metadata together, and I'm just going to run through this real quick, just because that's what Python notebooks are good at, and just kind of show you what I've done as we go through. And again, this code is readily available on our GitHub, and I encourage you to pull it up. Very simple environment to build if you're familiar with Python at all. So, I pulled in all this data together, and let's just take a look at, the first piece of metadata. So, here's that thing that looks awful familiar to what we were looking at just a minute ago. And then I built, I really like this Folium package. It's a Python library that helps you build maps, leaflet maps. It's basically a wrapper on top of leaflet. And so I'm going to build a little basin analysis. This is something, if I worked at a small water conservancy district in that region, I might want to build this, run it once a day to update it, host it on the web somewhere, the resulting map, and it might be informative to my constituents. I don't know. I provide the data to you. You're the ones that actually hopefully come up with these analyses. So I put together a little thing. These are really just some pretty simple methods that put together a map using Folium. So these are just some methods that build pop-ups and charts and things. You can see that it's not really an extensive amount of code at all. And at the end of the day, here's the method that actually utilizes all those methods. And I just create a map. You can even notice that I utilized every single method in our new REST API within this. So you can see how all these things tie together. Even our reference data, I pull down a long name for our networks based off of that. And so I just loop through and I grab all these things, create this map, and I add the markers to it. And at the end of the day, I also pull in a GeoJSON of the Roaring Fork Basin, just as a nice little outline to make it look nice. And I can see that all my queries were successful. And at the very end of the day, this is what I'm left with, which is a map of the Roaring Fork with all the snow tells, with the little clouds. These are meteorological stations. And I can look at the current year's SWE compared to its median. So, did a little bit better than median this year. There, maybe quite a bit better there. Take a look at all those. There's one reservoir in the region, and I want to look at how this water year has done for that reservoir. It looks like it's been relatively full. Didn't really draw down too much over the winter, and it's starting to fill again. And then last but not least, I pulled in the forecasts as well as so this is our April through July forecast. You can see that in January, we're making forecasts that have a really big spread because there's so much uncertainty. It might be a very dry year. It might be a very wet year. And you can see that typically our uncertainty tightens up as we get closer to the end of the year. And if we were to come back and look at this, at the end of July, we would expect that this value here would catch up and hopefully get really close to our 50 percentile. If we had pretty much an average year from here on out, we didn't see a ton of rain or snow at this point, then we would hope that the forecast that we made, which is right around 590,000 acre feet, we'd hope that the cumulative stream flow that we would see would meet that at the end of July. Because this forecast is an April through July forecast. And so this is the April through May so far cumulative runoff that we've seen. So that's really all there is to this. Again, I just wanted to show that with a relatively low amount of effort and that one-stop shop that is our REST API, that you're able to pull together a lot of different data from a lot of different sources and, hopefully keep your code really nice and concise and make something that hopefully is useful to you. Again, at the end of the day, we don't really know what people use this data for. We have our own uses, but we've decided that it's really important that we make it available to the public because at the end of the day, we're public servants. And I get really excited when people send me things that they've done with the data because it is such a powerful database, a lot of powerful tools that are built around it. And now with the REST API, I think we've really lowered the bar and allowed people to come in and start utilizing this data in a more, a way that more people can kind of get a hold of. And so I hope that's what we've achieved with it. We always like hearing from people what they like and what they don't like about things. I have included a contact link on the presentation. And so I'd encourage you to contact us if you have any questions or comments. There's some other links here too. We adjust our stream flow for forecasts, and you might want to know how that mass balance works. All sorts of different things. We have a really big effort to fix some air temperature bias that we had in our data sets, and that's an ongoing project. You can literally use the exact same modeling engine that we use in our forecasts if you'd like. It's machine learning. It's got a bunch of bells and whistles on it. You're welcome to fork that code and do your own thing with it. It's written in R. And then just tons of other ways to get at our data. And I would just encourage anyone to go ahead and do so. And I think with that, I'd love to take any questions if there are any. I know I kind of ran over what you typically like to set aside for questions.
No worries, Bo. Thank you so much. This was a really lively demonstration. Really great to see how the REST API just really puts that data at our fingertips. fingertips. So really cool to see. So like Bo said, if you do have any questions, please drop them in the chat. I do have a question of my own, and I'm not sure, Bo, if I missed this earlier, but you mentioned, the REST API is relatively new. When did this launch? And I'm curious, what have you guys seen it? What kind of reception have you seen? Are you looking at kind of user numbers or anything like that?
Yeah, we don't really track actual uses of it because we honestly just don't have the time. We're a very small organization. I think that's an important thing to consider with us. There are very few of us that work on this kind of stuff. And so that's not really a huge bar for us. We do just like some, basic Google Analytics on a lot of our HTML pages that have JavaScript enabled. And so we do get an idea how many people are hitting our various products, but we don't sort through any sort of like server logs to try to figure out how many people are hitting our REST API, especially considering we use it internally for different toolings as well. So we might be inflating those numbers quite a bit just with our own usage. And then we'd have to, filter out our own IPs and stuff to get at that. So maybe one day, but again, there's very few of us working on this stuff. So it's not a very important thing for us right now. But generally speaking, I've gotten nothing but really good responses from this concept that we took the SOAP web service that had a high bar to entry and made something that's, a lot of engineers, a lot of hydrologists, they're learning Python. Python has a lot of great libraries for utilizing REST APIs, R as well. A lot of these kind of higher level languages, I think, are really well suited for this kind of stuff.
Very cool. And we do have not a question in chat, but just a shout out to another helpful resource, that the API umbrella. I don't know, but we can bookmark that for later.
Sure.
Very cool. And it makes sense, right? Small organization, you have to focus where you can. And to that end, how what is next, I guess? I know you mentioned throughout the presentation there were almost like a small wish list, right, of things like, oh, hey, like, this this data point actually isn't as helpful, so we're going to cut that, like things like that. But where are you guys focusing on next? What's kind of where do you hope this kind of grows to from here?
Yeah, well, we're turning a lot of our development work currently kind of internally. It's kind of like the plumbing. It's not the funnest thing. You don't get a very exciting finish at the end. Whereas like maybe you paint your room in your house and, oh, that cost me $20 and it looks so great. We're really kind of focusing a lot more on the nuts and bolts internally that are hopefully going to help us. Our editing software. We're actually hoping to. We actually will be releasing better QA and QC flags, which we think will be super helpful for the end user. That's actually one thing that we're excited about. But that work's actually almost done, and we expect to implement it on October 1st. So we'll have a full QA QC flag set. Right now, we just have very minimal flagging for like suspect data. And edited data and then valid data. We're adding and expanding upon that quite a bit. So that'll be great. We're looking towards using automated QC, because one of the things that we get a lot of complaints about are our data. So oftentimes is not made publicly available because it comes in and it exceeds these profiles that we've set. Maybe it increased too fast, or the bad readings came through. And so we're actually hoping to use a variety of techniques to estimate data programmatically, without human revision as it comes in, so it can be made available. And then we always do a final, human eyes on it revision at the end of the day. But that'll hopefully allow our data to be kind of more up to date, because we used to just measure monthly data. Then we started measuring daily data. We still consider daily data what we really hang our hat on, but people want hourly and sub-hourly data now. And we're trying to deliver that, although the nature of the way we measure certain things makes that very difficult. But we're constantly working on things like that. So you won't see a whole lot in the public space development-wise, although you will in the NWCC apps. We're always making new products that will be popping up there. But a lot of our really like core work right now is kind of working on the database and cleaning things up.
Very cool. Makes sense. I know that's the, like you said, the kind of behind the curtains work that's not necessarily what people see, but that really keeps the machine running and running well and getting everything, getting that important information out to everybody. Um,
Mhm.
and my last question actually, and again, if folks have other questions, please drop them into the chat. But I'm just curious too, from your perspective, what 14 years with NRCS, a lot of the tools that I'm curious, a lot of the tools that you showcased, that was almost like a tip of the iceberg for us, but how much of that was actually publicly available when you first started? I'm curious how just kind of like the data landscape has changed since, you began working in this space.
I don't think anything I showed you was available.
Okay.
Yeah. Yeah, and then maybe even like you could tell just by like the update report, the one that I said that was
Yep.
sort of aging out, that one may have been available kind of right when I was starting out. But you just look at that and you just see it's this raw HTML, very little, CSS, and it's kind of quite obvious that that's the case. And so we're constantly striving to update our tech stack and bring these other things, interactive and and 508 compliant too is something that we're always striving for. So a lot of these, sadly, we have to spend a lot of time retooling things that already exist, and I think that's just the nature of the beast. But just in my short time, a lot of this stuff is kind of built from work that I started doing when I was just getting going, and the amount of change I've seen, not just in our database and in our products, but just in the whole, I mean, this is where you guys live, the Internet of Water, like it's wild how much things have changed.
Yeah.
We used to literally send out, space delineated data products. And that was the only way you could machine read or, just text files. And so now that the technology is so much better, we're already talking about setting up a GraphQL API that will be just probably a wrapper on top of this REST API. And we're just trying to keep pace with the direction that different things are heading in the consumption of data on the internet is a daunting task, but we're certainly better at it now than we had been for a long time.
Yeah, and stepping up to the challenge, right, which is the important part. So very cool. Okay, and I think we have one question in here. So this is from Derek Borba. Derek says, excellent work. Thanks for making the API interaction website available to the public. Great presentation. You might look at the point blank package in R for data validation. It allows you to extract problematic data and carry it throughout your analysis, perhaps even store it in a DB S3 and make it accessible if people really want to reassemble the raw data. So food for thought there from Derek. Thanks so much for submitting.
Yeah,
Okay.
no, that's definitely one of the places we're headed. We have a lot of different QC stuff that we do. Our new REST API, and this is brand new actually, can deliver the original data that came through. So kind of getting to that point there. Our SOAP Webservice never had that ability, but the new REST API, if you want, you can get the original data. You can pull down suspect data. We don't want to police our data. We want to make it available as much as humanly possible, but we also need those QA, QC checks in there to at least inform people of the issues that we know about it. And so we're hoping that we're getting better at that. That was certainly one of the biggest problems I saw within our organization over the last 10 years, and we've made leaps and bounds.
Yeah, to be those really responsible stewards. So awesome. Well, Bo, thank you so much. We are at the top of the hour, so I think we're going to close things out from here. Really appreciate you taking the time and chatting with us for this showcase. So really cool stuff. We'll be sure to include some of these resources in the Internet of Water Coalition website. So again, about a week after this is posted, you'll see the recording of the video up on the site, as well as a link to the presentation, some of those resources. If you want to know exactly when those will be posted, do sign up for our monthly newsletter, please. You can access that on the IOW Coalition website as well, and you'll be the first to know when those recordings are available. You can also follow us on Twitter and LinkedIn, great spots to keep up to date on ongoing webinars and new ways to share information, all the happenings of the IOW Coalition. So thank you again so much, Bo, for joining us today. Really appreciate it. And thank you to everybody on the line who joined us for this hour.